Here we go, friends. So make sure you finish that Think Central test. Mr. Baker's kiddos, I just emailed Mr. Baker to see if you finished. My kiddos, I sent emails to those in between science and now who I don't have your test from. So if it is not finished, that is your #1 priority once we finish up here. But first, let's go ahead and correct our math problems from yesterday.
Wait, you have them on a slide now?
They've been on a slide. I've been sharing this with you guys in Otis, like I share it the next day. So this morning I added this slide in Otis. So you could have it corrected already.
This triplet is blurry on my screen, so I can't exactly see the answers.
Okay. Is anyone else having that problem with it being blurry?
No, but it's sort of small, so I can't see it.
All right. Well, let's go back to the old way to do it then.
Not blurry.
Wait, no, stop. My iPad's doing something. It's trying to install an update, but now's not the time.
Lol. Lol. LOL.
Technology. Oh my goodness. Well, I'm gonna need you guys, here, I'll just read through them for right now from this, because the iPad's installing an update and I can't make it stop. So on the homework side, #1 is 1 2/5. #2 is 2 1/4. #3 is 7. #4 is 5 2/8 or 5 1/4. #5 is 1 3/9 or 1 1/3. #6 is 2 1/7. #7 is 3 2/5. #8 is 15 4/8 or 15 1/2. #9 is 10. 10 is 5 2/7. If you guys can mute yourselves for right now, that would be helpful. #11 is 3 1/7. #12 is 10 2/3. Number 12 is 100 2/3. 13 is 1 2/3. 14 is 2 4/8, or 2 1/2. And 15 is 2/6 or 1/3. #16 is 7 6/8 or 7 3/4 inches. 17 is 12 2/4 or 12 1/2 hours. And 18 is 8 2/3 ounces. Any questions on that first page? All right, on the other side, #1 is 8. #2 is 15. #3 is 24. The answers for 4, 5, and 6, you could have lots of different things. So I'm not even gonna read through those because our answers could be different from each other. #7 is less than. 8 is less than. 9 is greater than. 10 is greater than. 11 is less than. 12 is greater than. Oh, come on, iPad, go faster. #13 is Rosa. 14 is less. And 15 is Damien. Oh, Sean's happy. He got them all. Any questions on any of those, guys?
On #6, I did 2 and 12.
That's exactly what my book put for #6.
Oh. But I don't know what I just read.
You're good.
Oh, never mind. 6 and 4.
Okay. That works too. Yep. Because that's 3/4 and 3/4.
And
Other questions?
4, I did 18 and 2. Well, 2 and 18.
Okay. Other questions? Jackson, I see your hand up.
On #4 and 6, I don't really get how to do it.
Okay. So the kind of tough part about these is that you're having to find something that works across both sides, right? So for number 4, well, see, I came up with a different one for number 4. For number 4, I thought, okay, well, if I did 18 underneath the 4, then I could do 18 divided by 2 is 9, and 4 divided by 2 would be 2, so I would have put a 2 on top.
Miss
Okay.
Triplet,
Yes.
that happened to. That's what I was thinking yesterday too. The same
Awesome.
thing.
All right, other questions?
Would 5/20ths work on number 5?
Number 5, 5/20ths. Yes, it does, because you're dividing both the top and the bottom by 5.
Thank you.
Other questions?
Nope.
All right, let's go ahead and take out our student activity books. Unfortunately, right now, while my iPad is still updating, I can't put it under the screen, but we can still talk about it and do it together. And then as soon as my iPad is done loading, I will get it under there so you can see. So we, yesterday we did adding and subtracting, mixed numbers and fractions that had like denominators, right? The number on the bottom, the denominator, was the same. So it made it super simple because all we had to do was add our numerators and then our denominator stayed the same. Unfortunately, that's not the case for today. Today, we're moving into adding and subtracting with those unlike denominators where the numbers on the bottom are different from each other. So we can't just add them or subtract them if the denominators are different. We have to find a common denominator. We need to make one of the fractions, well, or both of them, into fractions that are equivalent to something else that will give them the same denominator, okay? So the first part on 1.7 is going to show us how to use some models to help us choose our common denominator. So it says to add two fractions, they must have a common denominator. Somebody read me the directions there in bold, please.
Use the models to help you rewrite each sum so the fractions have a common denominator. Below the model, show how to find equivalent fractions numerically.
Numerically, good. So, oh, I think it's ready. I think it's ready. Let me mirror it real quick. That's some pretty
Oh,
good.
thank you so much. I was kind of lost.
You're lost. All right, let me get it all plugged in and ready to go. All right, guys, thank you for being patient. Let me get my screen mirrored over here. Share screen. That's the one I want to share. Share. Bam, there it is. You can see my book?
Yes, thank you.
All right, so let's take a look at this now then, okay? So for the first one, we have our 1/2 plus 1/3. So for the 1/3, let's look at the second model, and I'm going to put some lines in here to kind of show you, because they didn't really show us a 1/3 model, but 1/3 would have been just this part from here to here, right? So I can't just add 1/2 and 1/3. Actually, I see how they did it. Let me erase my lines. I apologize. Back up, rewind. They put 1/2 and then they added another third to it. But we need to find a common denominator, a number that can go on the bottom that works for both halves and for thirds. So we're able to add those together. And so you'll see they broke it into 6, because in 6, I could say 1/2 is the same as 3/6. 1/3 is the same as 2/6. Do you guys see how we did that? How 1/2 is the same as 3/6
Yeah.
and 1/3 is the same as 2/6? Okay. But now we're going to go to that equivalent fraction part of it. How do I change 1/2 to 3/6? What can I multiply both my numerator and my denominator by to make 1/2 equal 3/6? Remember, it's got to be the same number.
3, 6.
3. I can multiply the top and the bottom by 3. How about 1/3? What can I multiply my numerator and my denominator by to get 2/6?
2.
2. 1 times 2 is 2. 3 times 2 is 6. What's my common denominator that I have now so I can add these? What's my common denominator?
6.
6. Common means the same, right? If something's common, it means it's the same between multiple things. So my common denominator is that denominator that's the same on both fractions. And in this case, it's that 6. My common denominator is a 6. Can I add 3 6 plus 2 6? Yes. What is 3 6 plus 2 6?
5, 6.
5, 6.
5 6. You got it. Okay. Let's look at the next one. On the next one, we have 1/4, right? 1/4 plus 2/3. I can't just add those together with the denominators looking like they are. So I had to find a different denominator that I could use. And in this case, we went to 12ths because I know that I can put 4 into 12 and I can also put 3 into 12. So that's a great common denominator that I can use. 1/4 is equal to how many 12ths?
3 12.
3 12ths, you got it.
3
2/3 is equal to how many 12ths?
8 12.
4,
8
8, 12.
8 12ths, right? I heard a 4 in there. The 4 would just be 1/3, but we want 2/3, okay? Can I add 8 12ths and 3 12ths?
Yes.
Yes.
What is it?
11 12ths.
11 12ths, good. But how did I get to that point where I could have my common denominator? Well, I had to do some thinking. Okay, 4 and 3 both go into what number? 12. 4 and 3 both go into 12. 4 goes into 12 how many times?
3 times.
3
3 times.
So if I'm multiplying the bottom times 3, I have to multiply the top times 3 also. 3 goes into 12 how many times?
4 times.
4 times. Well, if I do 3 times 4, I have to do 2 times
2
4.
times 4.
2 times 4.
You got it. And I end up with 8 12ths. What is my common denominator?
12.
12.
12.
12 is my common denominator, yes. Now I have 1/4 plus 1/2. I could do a couple different ways for this one. I could do this a couple different ways. There are multiple common denominators that I could use, okay? I could do 8s, right? Because 4 goes into 8, doesn't it?
Yeah.
And 2 goes into 8. How
Yes.
many 8s are in 1/4?
2.
2. 2 8s. How many 8s are in 1/2?
4.
4. 4 plus 2 is
8. I mean,
6.
6. So that would have given me 6 8. That's one option of how I could solve it. But there's another way I could do it. A way that's a little bit easier because I can use smaller fractions. And here's a hint I'm going to give you. When you are looking for your common denominator, the first step you should do is see if your smaller denominator will go into your larger denominator. Does 2 go into 4?
Yes.
It does. So I can use 4 as my common denominator. Because how many fourths are there in 1/4?
1.
1, right? 1/4 is 1/4. How many 1/4 make a half?
2 fourths.
2.
Fourths. Can I do 1/4 plus 2/4?
Yes.
Yeah.
Yeah.
3/4.
3/4. Now tell me this. I got 2 answers, right? Are those answers the same or are they different?
They're the
The
same.
same.
They're the same. They're equivalent fractions. So it's just 2 different ways I could do it. 2 different ways I could solve that one. Okay? Which common denominator would you choose? Somebody want to share? Which one would you choose and why would you choose that one?
I would choose the 4th because it's a small, it has bigger parts and it's like a smaller fraction basically.
Awesome. Morgan, how about you? Which one would you choose?
I would choose the fourths as well because it's smaller and just easier to get into
Okay,
since
awesome.
one of them is already a fourth.
All right. All right, guys, look at number 4. Does 1/2 plus 1/3 equal 2/5? Send me in your chat. Does 1/2 plus 1/3 equal 2/5? Send it to me in chat. Yes or no?
Whoever has a piano in the background, can you please mute?
Excellent. I must be doing my job because I see a whole lot of no's. No, it does not. It does not equal 2/5. Have we said anything about adding the denominators together?
No, that's
No. No, 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 no. You do not add the denominators. I love those all caps there, Hazel. Do not add your denominators together, okay? And you have to have the same denominator in order to even add your numerators. There's some rules. There are some big rules, just like I'm sure you guys have rules in your houses. There are big rules when we add and subtract unlike fractions, and they're unlike because they have different denominators. All right, so let's solve some of these. Okay. So for number 5, 7/10 plus 1/5. Remember that first step I suggested is to see, okay, does my smaller denominator go into my larger denominator? Does 5 go into 10?
Yes.
Yes. So that means I can make my 2 fractions have a denominator of 10. Okay. I'm going to look at my first one first, 7/10. Is that going to change? No, that's still 7/10, right?
Yeah.
How about 1/5? I need to make 1/5 equal something over 10.
2/10.
2/10.
2 times.
So I think, Jaslyn, I think I heard you shout out 2/10 first. How do you know that? How do you know that it's 2/10?
Because you can divide. Well, since they're equivalent fractions, that's how I know, basically.
But how did you make them equivalent fractions? How did you know what number to put up top?
Because 5 times 2 is 10, and then 1 times 2 is 10.
Yes.
1 times 2 is 2.
Yes. Because if I need my denominator to be 10, I say, okay, well, 5 times what gets me 10? 5 times 2 gets me 10. And we have to be fair, so whatever we multiply the denominator by, we have to multiply the numerator by the same thing. So that gives us 2/10. What's 7/10 plus 2/10?
9/10.
9/10.
9/10. Let's look at the next one. 11, 3/11 and 1/2. First thing we check, does 2 go into 11?
No.
No. Well, shoot. Now I need to find a different common denominator. Okay. So I know 2 doesn't go into 11. I'm going to count by 11. So I've got 11. Next is 22. Does 2 go into 22?
Yes.
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 By
That's
11.
going to be my common denominator. 22 is going to be my new denominator. Okay. Now I have to figure out what those numerators are going to be. So let's deal with our 3/11 first. How many times does 11 go into 22?
2.
2, right? 11 times 2 gets me to 22. If I'm multiplying that by 2, I have to multiply the top by 2. 3
6.
times 2?
6.
And then the other one is
Hang
11.
on. Nope, nope, nope. I don't want you to just shout out, right? We wouldn't be doing that if we were in the classroom. 1/2. How do I get from 2 to 22?
Multiply 12. No, 11.
Times 11, yes. If I'm multiplying the bottom by 11, I better multiply the top by 11. What's 1 times 11?
11.
11. Can I add 6 22nds plus 11 22nds?
Yes.
What do I get?
Yeah.
What do I get?
17, 26.
17,
22nds.
22.
Let's look at the next one. 1/6 plus 3/4. Look at my smallest denominator first. Does 4 go into 6?
No.
No.
So now I'm going to start counting by 6s. So I know 4 doesn't go into 6. Next comes 12. Does 4 go into 12?
Yes.
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 That's going to be my new denominator. That's my common denominator. So 1/6. 6 times what gets me 12?
2.
6 times 2 gets me 12. So I have to multiply the top by 2. End up with 2 12ths. 3/4. 4 times what gets me to 12?
3.
3.
3.
3.
What's 3 times 3?
9.
9.
9. Yep.
11.
Together, what's my answer?
11
12.
12.
11 12. Yes. If you've got this, go ahead and do 8, 9, 10 on your own. If you don't, I'm going to keep talking through them, okay? But if you think you got it, you can start working ahead a little bit, but only through number 10. Stop when you finish number 10. All right. 3/8 plus 2/5. 5. Can 5 go into 8?
No.
Nope. So I'm going to start counting by 8. I've got 8, 16. Does 5 go into 16?
No.
No. 24. Does 5 go into 24?
No.
No. 32.
No.
Does 5 go into 32?
No.
No. 40. Does 5 go into 40?
Yes.
There's my common denominator. So now I have 3/8. 8 times what gets me to 40? 8 times 5, right? 3 times 5 is then 15. And I have 2/5. Well, 5 times what gets me to 40? Oh, 5 times 8. 2 times 8 is
16.
16. 16 plus 15 is 31 over 40. All right, let's look at my next one. 3/10 and 4/15. Again, start with my smaller denominator. Does 10 go into 15?
No.
No. And here's the thing. I bet on some of these, a lot of you might just jump to a denominator of 150. Because you know that 10 times 15 is 150 and they're both going to go into it. You can do that, but there's easier ways with smaller numbers. So I know 10 doesn't go into 15, so if I count by 15s, what comes next?
30.
30.
Does 10 go into 30?
Yes.
Yes, it does. Isn't that much nicer than having a denominator of 150? I think so. So 3/10 is how many 30ths? 10 times what gets me to 30?
3.
3. What's 3 times 3?
9.
9. So 3/10 is the same as 9/30. And then I have my 4/15. 15 times what gets me to 30?
2.
2. What's 4 times 2?
8.
8. 9 plus 8 is 17.
17.
Over 30. Okay. Same thing. Well, hang on. On number 10, some of you might have just jumped to 32 for your denominator because 4 times 8 is 32. But can 4 go into 8?
Yes.
Yes. Isn't that much easier to just keep 8 as my denominator? Because my 5/8 is still 5/8. My 1/4, all right, well, 4 times what gets me to 8?
2.
2. What's 1 times 2?
2.
2.
2. 2/8 plus 5/8 is?
7/8. 7/8.
You got it. I will tell you guys, I much prefer, I told you guys this yesterday, the horizontal work, I don't like as much on these. I would much rather stack them vertically and do them vertically if I had the option. I think it's easier to look at. Let's look at number 11. Hang on, those of you that worked ahead, how did we do?
Good.
You did okay? Okay.
Yes.
Number 11, Bashir walked a 1/4 mile to his friend's house and then another 3/8 mile to the park. Make a diagram to help you find the distance he walked. So, I mean, I guess if I was doing a diagram, I could do my 1 whole, right? And I'm going to divide it into 4ths first. And walk 1/4 to his friend's house and then 3/8. So if I cut my 4ths in half, I've got my 3/8 there. And then I could use that to say how far he walked. Or I have 1/4 plus 3/8. And let me show you why I like doing it this way better. Because now I could say, okay, well, does 4 go into 8? Yes, it does. So that's going to be my common denominator, right? I need both of these to be fractions over 8. So how do I get from 4 to 8?
Times 2.
Times 2. What's 1 times 2?
2.
2. How do I get from 8 to 8? Times 1.
1.
Right? That fraction's not going to change. So what's my answer going to be?
5/8.
5/8. You got it. All right. Deep breath. Shake it out. We've got 2 more to go. We've been sitting here working lots, working hard. Let's take a look at number 12. Meg and Marcus are making a latch hook rug. Those are fun. You guys probably don't know what that means. I did those a lot as a kid. So far, Meg has finished 2/5 of the rug, and Marcus has finished 1/4. What fraction of the rug have they completed? So I need 2/5 plus 1/4 to solve this problem. Right? Can 4 go into 5?
No.
No, can't.
Nope.
No.
So then I'm going to start counting by 5. Can 4 go into 10?
Yes.
No. 4 can't
No.
go into 10. Can 4 go into 15?
No.
20.
No. Can 4 go into 20?
Yes.
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 Yes. That's going to be my common denominator. Both my fractions are going to have 20 for the denominator. How do I get from 5 to 20?
Times 4.
Times 4. What's 2 times 4?
8.
8. How do I get from 4 to 20?
Times
Times
5.
5.
Times 5. What's 1 times 5?
5.
5. 8 plus 5 is?
13.
13. What's my denominator?
20.
20.
20. So my answer is 13/20ths of the rug. Okay, we've got one more. Of the songs downloaded from the music website on Tuesday, 1/6 were country songs and 3/10 were rock songs. What fraction of the songs were country or rock songs? We have to add those two together. 1/6 plus 3/10. Let's find that common denominator. Can 6 go into 10?
No.
Nope, I'm going to count by 10s. Can 6 go into 20?
No.
Can 6 go into 30?
Yes.
Yes.
It can. How do I get from 6 to 30?
Times
You
5.
multiply by 5.
Times 5. What's 1 times 5?
5.
5, right? Because whatever we do to the bottom, we do the same to the top. How do I get from 10 to 30?
Times 3.
Times 3. What's 3 times 3?
9.
9. 5/30ths plus 9/30ths gives me what?
14/30.
14/30ths of the songs. Whew. Send me a 1 to 5 ranking. 1 is I don't know what's going on. 5 is I got this.
3.
All right. So I see we're a little bit all over the place, which is perfectly fine. It is time. We've got 5 minutes left until lunch, not until lunch, until recess. So what we're going to do is you guys do have your homework page to work on, which is page 13 and 14 in your homework and remembering book. I am going to, in just a minute, take out the planner and we'll write some stuff down in the planner. Those of you who are in Mr. Baker's class, if you're good and you don't need my help anymore, you can go. My class, you need to stick around while we write in our planner. And then afterwards, you can make a decision whether you want to stay on for that first 5 minutes while you're working on your homework so you can ask questions, or whether you think you're good and you can log off and work on your own. But don't go yet, because first we need to write in our planners, okay? So everybody take out your planners.